Okay, so can you all see my screen?
Yes, sir, we can see.
Okay. So what we're going to do today is that we're going to solve all the assignments and then the tutorial questions I sent to you. So
Okay.
the very first assignment I sent to you, which was assignment 1. Okay.
Okay, sir.
For assignment 1, question 1, it stated that you should define what a tuned amplifier is, right?
Yes, sir. Yes, sir.
Okay. So can any of you give us an idea of what they understand by a tuned amplifier?
Okay. A tune, a tune amplifier. If I is speaking,
We cannot hear you. Malik, please turn off your video so when you speak, we can hear. The video is also taking away some of your bandwidth.
oh,
You keep turning it on and off. It's okay now. So you can speak. We are listening.
a tune amplifier involving a resonant circuit and are intended for selective application within a narrow band frequency.
Okay, so
That's
basically,
how I understand it.
all right. So basically, when we talk about a tuned amplifier, okay, what we are saying is that an amplifier which involves a resonance circuit. When we talk about a resonance circuit, what comes to mind? It means a circuit that has resistance, has inductance, and capacitance in it, okay?
Yes.
That is a resonance circuit. And basically, what these circuits are used for is that they are used for selective amplification. When we talk about selective amplification, what it means is that they are used to select some particular set of frequencies. Okay. So, tuned amplifiers are employed in broadcasting where you can be able to select a particular channel, okay, in a narrow band of frequencies. So radio and TV amplifiers employ tune amplifiers to select one broadcast channel from among the many concurrently induced in an antenna or transmitter. Okay.
Yes.
So basically, that is the simple definition for a tuned amplifier. So you take note,
Amplifier.
yeah. So take note of that. You have that in your lecture notes under tuned amplifier. Now,
Yes, please.
one thing about me you should know is that I don't believe in chew and pour.
Oh, okay.
So I don't expect you to write word to word, but there are certain things you should always note. For instance, when you are explaining what a tuned amplifier is, you should ensure that you are able to tell us that it involves a resonance circuit.
Resonance circuit.
And its main purpose is used for selective amplification within narrow frequencies. So you put it in your own wording and then you explain, okay?
Okay, sir.
All right. Okay. So once you have found that, there was another question, which is, I think, the trial question. The next question was what? The assignment 1. It said you should enumerate the fundamental difference between wide amplifiers and tuned amplifiers.
Yes, sir.
Okay, so when you take a tuned amplifier, for instance, when you have, can you see what I'm drawing?
Yes, sir.
When you have this, okay, where you have your frequency here and then you have your gain here, okay? For a tuned amplifier, you would have the frequencies, okay? The gain would fall at low frequencies and also fall at what? Higher frequencies. So assuming this frequency here is 0 hertz, and we have frequency here to be 100 hertz, you realize that for tuned amplifiers, the gain of the amplifier falls at what? At the lower frequencies and also at what? The higher frequencies. Okay? Now, when we take the wideband amplifier and we take this to be 0 hertz and we take here to be 100 hertz. Okay, this is our frequency, this is our gain. Okay? What happens here is that the gain remains constant for wideband amplifiers for a wide range of frequencies. So what you would find in your notes is that for the wideband amplifier, you have something like this. So for this section of the band, you have your the gain of the amplifier remaining what? Constant for a very wide range of frequencies. However, for the tuned amplifier, you have the gain falling at lower and higher what? Frequencies. But with the wideband amplifier, the gain is constant at a wide range of what? Frequencies. So what we have here is what we call what? The wideband amplifier. Okay?
Yes, please.
So basically, when you are asked to state the fundamental difference between one wideband amplifier, all you need to say is that the gain of the tuned amplifier falls at lower and what? Higher frequencies. And then for the wideband amplifier, you have a constant gain within a wide range of what? Frequencies. That is the basic or the fundamental difference between the two of them. Okay?
Okay. Okay.
Is there any confusion here?
No, sir. So you're saying that for the wideband, the amplifier have constant gain from DC.
Yeah, so let me show you something. So what I'm basically saying here is that, for instance, let's assume this is a frequency response, okay? And then this is our frequency, and this side is gain, okay? And then let's assume that here we have 10 hertz, and then here we have 20 hertz. So in between this and this, we have a bandwidth of what? 10 hertz, right?
Yes,
Because if you want to find the bandwidth, you subtract this from this. You subtract this one from this one, and that will give you what? Your BW, or which is the same as bandwidth. Now, what we are saying is that, assuming we have some gain, let's say here, the gain here is 1, the gain here is 2, the gain here is 3, and the gain here is 4, we have 5, okay?
okay, sir.
For wideband frequencies, if the gain rose from 0 to about, let's say, 3, or let's say it rose from 2 to 3, once it gets to 3, it stays constant at 3 for a wide range of frequency before it falls back down. Okay?
Okay.
So you realize that this section where I have shaded, where I'm trying to shade, that is where you have a constant gain, because the gain remains constant at 3. Gain is normally measured in what? dB. Okay?
Yes, please.
Okay. So here, the 3 dB gain, the gain of the amplifier, okay, or the level. When we talk about gain, I hope you understand what gain means. Okay, so let's take, for instance, I have been given a signal, and the signal is 20 hertz, and I'm supposed to amplify the signal to what? 40 hertz, or I'm supposed to increase the signal from 20 hertz to what? 40 hertz. What this simply means is that 40 divided by 20, that will give you what? 2, right?
Yes, sir.
So the gain of my amplifier needs to be 2 before I can achieve 40 hertz. Okay?
Yes, sir.
Gain is basically the factor with which amplification of a signal is done, or it is the factor by which a signal is multiplied to increase its amplification. Okay?
Okay, sir.
Okay, so basically what we are saying for wideband amplifiers is that for wideband amplifiers, the gain remains constant for a wide range of what? Frequencies. So this section is termed as what? The area where the gain remains constant. And you would realize that if we are to trace this down and trace this down, we might get about 12 hertz here, and we might get about 18 hertz here. Okay? It means that
Okay.
within a bandwidth of what? 6 hertz out of 10, okay,
Yes, sir.
there is amplification and the gain is constant. That is why it is termed what? Wideband amplifier. Do you understand?
Yes, sir.
Okay. And then once this we understand for the wideband amplifier, then what we are saying for tuned amplifier is that for the tuned amplifier, the gain starts from the lower frequencies. It remains constant at the lower frequencies, goes up to a certain peak, and then falls again at higher frequencies. Do you understand?
So please go back again.
So for the tuned amplifier, don't worry, I am recording this lecture. I'll upload it onto your platform, so you can listen and watch it several times. What we are saying is that
Okay.
for the tuned amplifier, okay, we said tuned amplifiers are used for what? They are used for selective amplification, right?
Yes.
So if they are used for selective amplification,
Yes, sir.
the gain of the amplifiers don't remain constant for a very long time. Okay?
Okay.
However, the gain only remains constant at very low frequencies and at higher frequencies. So when you take the definition of the tune amplifier, which says tune amplifiers are amplifiers involving a resonance circuit and are intended for selective amplification within a narrow band of frequencies. So the amplification is done within what? A narrow band of frequencies. Do you understand?
Yes, please.
So you would realize that when you take this side and this side, you will realize that the bandwidth from here to here, it's not a very huge bandwidth. It's a narrow band, okay? So you realize that at this particular point, there is a different gain. At this particular point, there is a different gain. When you match them to their corresponding frequencies, you realize that the frequencies are different, okay?
Okay, sir.
Like that. So that is what we mean by what? Tune amplifiers, and then wideband.
And why?
So the basic difference or the fundamental difference has got to do with how the gain behaves with respect to what? Frequency. So after this, when you take the video, you can go through and then take your notes in how you answer those questions, okay?
Okay, sir.
Okay, sir.
Now, the next question says that what is
State.
the advantage of twin amplifier over a narrowband amplifier? This is very simple. Twin amplifiers can select different frequencies as needed, okay?
Okay.
So note that. And then the next question also states that state two applications of twin amplifiers. Number one, they are used in what? So the
Resonance.
application, just a second. By the way, this lecture will end in some few minutes. I'll send Isaac another link so that you join that one, okay?
Okay, sir.
So the applications of tuned amplifier. Number one, it is used in what? In radio broadcast. To select desired what? Desired channels from many channels. Okay?
Okay.
Now, when we come to instrumentation or systems that deal with instrumentation, you can also use tune amplifiers because they are used to select or do selective amplification. You can use tuned amplifiers to isolate signals in instrumentation systems or in systems, okay? So number two, tune amplifiers can be used, just a second, can be used to isolate signals, okay? When you are reading, take your time and look for other applications. But if you are going to be examined, you are likely to be examined on only 2 of them, okay?
Okay, sir.
All right. So that is it for that question. State 2 applications of tuned amplifiers. Now, the next question on the trial questions, we have,
What's the calculation?
yes, we have a calculation there. So since the time for this meeting is going to end in 5 minutes, I would wait for us to start that calculation, or the assignment 1 question 2. We'll start that one in the next section, okay?
Okay, sir.
But in the meantime, assignment 1 question 1, is there anything you don't understand, or is there anything that is confusing you?
We are okay here.
Okay, that is
No,
good.
I was my line was breaking, so I didn't get the fundamental differences between the wideband and the tuned
Okay,
amplifier.
what we said basically was that, can you see my screen?
Yes, I can see your screen.
Okay, what we said basically was that what you see here is what we termed as what? The wideband amplifier frequency response, okay? Now, for the wideband, for the frequency response for wideband,
Sir.
what we are saying is that the gain, even though it may rise from a certain gain value, it could rise to say 3 and then remain constant till a certain frequency. So when you take, for instance, when you take the frequency where it started rising, okay? So when you take, for instance, here, the frequency, let's assume the frequency where it started rising is about 5 hertz. And then at about 11 hertz, okay, the gain remained constant till it got to about 18 hertz. So you realize that the gain of the amplifier was constant for a very wide range of frequencies. Do you understand?
Yes, sir.
Yes, sir.
So that is why we term it as what? Wideband amplifier. So the main or the fundamental difference is that for wideband amplifier, the gain remains constant for a wide range of frequencies. And then for the tuned amplifier, because we initially defined it to be an amplifier that is used for what? Selective amplification. It is able to have the gain constant at only low frequencies and what? High frequencies. Okay?
Yes, sir.
And within the narrow band of frequencies, which defines the tune amplifier, you have the gain increasing and decreasing. Do you understand?
Yes, sir.
Okay. So basically that is it for
The fundamental differences.
This section.
assignment 1 question 1. So let me send you the link for that one. Will start at 10, but I can start it early though. So I'm trying to send it to you via WhatsApp. I don't know, but my network is misbehaving. I'll send it to you soon.